Let us first train 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 the machine to learn certain things. So we'll train the machine using the data set, using the huge data set, and at the back end certain machine learning algorithms we will learn, and based on these data sets it will make a predictions out of it. For example, consider the weather uh, weather recognition. So having which having which having which having which having which day it was raining, it was sunny. So it will study the all those previous data sets and make a prediction that today it will rain or not. It a heavy rain, or it is a sunny day. Like that it will make the prediction. This is all about machine learning. So it is used in various applications like speech recognition, natural, all these it will be, or in all these fields it is used. So there are three types of machine learning. Supervised is a supervised learning. Supervised learning is nothing but it is a type of machine learning where the model is trained based on the, for example database. So it is of database of pay to the clinic. So the database consisted of gender, age of the patient, healthy. And in this example of supervised learning, we train the model in such a way that it will be able to predict it will be able to predict whether the new patient is healthy or sick for the new patients based on the gender as well as age. For example, the clinic arrives into the clinic. If he is a male and if his age is, the model the model the model would be able to classify if the patient is healthy or sick based on the patterns it during its training. So unsupervised, second one is unsupervised learning. Unsupervised learning algorithm is nothing but it will have the inputs without any label data. So it is having only two categories: gender. Consider this the same of the patient sets of the patient entering into the clinic, and it is a unlabeled data where only gender and the age of the patients is available, health status. Okay. Next, here in the unsupervised learning, it will find the patterns or the groupings in the data by cluster or gender. For example, the algorithm might group the patients into the clusters such as younger healthy patients or older sick patients. Like that, it will draws the insight from it. And third is the reinforcement learning. Agents like it's like a trial and error method. For example, if we give the input like of an image which consists as a it is a consider as a of an image of an initially machine makes a prediction that it is a mango. If it is if it is if it is for example, the apple might be round, so mango might be a little round. And certain predictions it will make it, and it will ask us for the feedback, and we'll give it it's a wrong, the image is an apple. So next time when you give the same, so the system makes its updation inside, and next time it will shows it's an learning. Next is the data visualization. Data visualization is nothing but it is the graphical representation of the data that helps the people to understand and trends and draw the useful insights or the information from it, and use like elements like bar charts, graphs, maps, pie charts, etc. So to extract the meaningful insights or the information from the data set. So we'll be using data visualization used and machine learning algorithms will be used and to make the make the prediction and put that prediction as a visual representation using all those Python data visualizations libraries. And for this we will be using Python, and the software we can use charm or we can use the Jupyter notebook for running these programs. So let us first understand the first program is develop a program to create the histogram for all the numerical features and analyze the distribution of the feature box plot for all the numerical identify any outliers and use the California housing dataset. What this program develop a program in order to create the histogram. Histogram is nothing but it is a type of bar distribution of the data set, okay, in the form of bins or the intervals. For example, this is the histogram. So this is the histogram. So it will be having the bins. This is the histogram. So this is called as bins. For example, this is 0 to, for example, consider it as 25. So this 25. So this is one bin, 0.25 to 1, 1 to 1.5. So these are called as bins or intervals. So to create the program so that it will create a histogram for all the numerical features and analyze the distribution for each of the feature, and also for the same data set we need to plot the box plot um, of the numerical features by the outliers is nothing but we understand the histogram is a type of present the distribution of the data set in the form of bins or intervals along the x-axis and the frequency or the count along the y-axis. That is histogram. And then the next is and which is having minimum value, maximum value, all that. And outlier is nothing but before the minimum value and the values which is after the maximum value, that are called as outliers, the outside points. Okay, next is will be for this we'll be using the California housing data set. California housing data set is nothing but, here I have run the program using the Jupyter notebook. So this is the California housing data set. It consisted of certain fields, that is it is having, this is the California housing data set. It is having around 20,639 entries, and these are this is MEDINC is nothing but median income. What is the median income of the peoples living in California, and what is the house age, and then the average number of rooms in California, average number of bedrooms, the population in the California city, average occupations, average number of peoples which are living in one household, then the latitude of the house, longitude, and the median house value. What is the value of the house in some dollars, $1,000 or hundreds of dollars, like that. So these are the different features which is present in the data set, and we need to use only the numerical data, like as it is shown in the as it is given in the question. We need to analyze only the distribution of each of the features which is having the numerical data. Okay, first is import. So for that we need to import pandas library. So pandas is used for, it is a library, Python library, which is used for data manipulation. Means if we want to do some of the changes in the data set and we need to do the analysis, we will be using pandas library, and we are importing pandas as alias as pd, and we need to import numpy operations on the numerical values, we will be importing numpy. And then cborn. Cborn is nothing but it is a data visualization library based on the matplotlib. So matplotlib, it is used for creating static, animated or interactive visualization. For that we will be using matplotlib library. And then matplotlib library. Then is a scikit-learn. Scikit-learn is also one library, and we are importing from the scikit-learn.dataset, we are fetching the California housing dataset. So California housing dataset is already present. So we are just fetching that dataset. As I have already explained, it contains all those house age, median income, all those features. So we are fetching that library, and then we are loading the California housing dataset. So fetch California housing as frame underscore as underscore frame equal to true is nothing but we are loading the California housing dataset as a pandas data frame, and it is storing in the data variable. So data.frame is nothing but data frame is nothing but it will extract the dataset as a data frame, and we will be storing it in the housing underscore df variable. Data frame is nothing but it is a 2D tabular data structure in pandas. So it can be thought of as a table or a spreadsheet which consisted of rows and columns, like we'll do in consisted of data frame is nothing but it will classify the data as rows and stores the data as rows and columns so that it is easy for storing and accessing. So it will extract the data as a data frame and store it in the housing underscore df variable, and I have printed it. So this is the data set which I have printed. So it is showing only few rows since the data set is huge of around 20,000 lines. And then we need to create a histogram. So histogram, so housing underscore df means it contains the data set as a data frame, means rows and columns. So we are selecting the data type. We need only the numbers, right? We need to plot only the numerical features. So np means numpy, we have aliased it as np dot number dot columns. That is nothing but it retrieves the names of the columns which stores only the numerical data. For example, all these having numerical data like right average bedrooms, this is numerical data. Population will extract all the features which is having numerical data. That's what next step is. We need to plot an histogram as they have specified here. We need to plot a here histogram. So first what we will do is, so plt dot figure, so figure size should be 1510, the width and height of the figure. And for I feature in enumerate. So enumerate is nothing but it is a function in the Python which is used for looping through an iterable. For example, it will iterate through all the numerical features. So numerical features is here. We are storing each of the feature. For example, median, all the features, right? House age, first it will iterate through median income, then through house age, then through average home. So we are using enumerate to iterate through all the numerical features. Next is a subplot. Subplot is nothing but the histogram should have 3 subplots which consist of 3 rows and 3 columns. So let's consider here. So this consisted of 3 rows 1 2 3, and there are 3 columns 1 2 3, and each subplot or the subgraph will be having, we have plotted different features like distribution of latitude, distribution of longitude. So all these are the different features we are plotting in the different subplots. So this is the line for that. Next, here this is the line for that, and we are plotting from the SNS is nothing but cborn. We are plotting, we are using the histplot function, and we are plotting housing underscore df of feature. We are plotting each of the feature. Okay, and KDE equal to true is nothing but KDE is nothing but kernel density estimate plot. It will create a smooth curve. It will for representing the distribution of the data. Smooth curve is nothing but like this, which will be helpful for us for the distribution, like this. So this is the smooth curve. This is the smooth curve. So these can be plotted by using the KDE. Next is a color. Color equal to blue. So color equal to blue and bins equal to 30. Bins equal to 30 is nothing but 30 different boxes like this. These are bins 1, 2, 3 like this. 30 bins we have considered, and we are plotting and we are giving the title as distribution of feature. Distribution of the particular feature as they have shown here. This is the distribution of median income, distribution of house age, like that. And then color equal to blue, and then plt dot tight layout. Tight layout is nothing but this function. It will avoids the adjust the layout and avoids the overlapping of the elements. And then finally plt dot show means it will render the histogram onto the screen. So that is plt dot show does. And same function will be plotting box plot. Just we are using box plot instead of hist plot, and then we are plotting all those features. And then next is we need to also print the outliers. So we are using these outliers. So outliers is nothing but we will be iterating through all the numerical features using the for loop, and we'll be dividing the data into three. First one is Q1, Q3. Q1 is nothing but first quartile. First quartile will be considering it as 25%. Q3 is third quartile, which is 75%. And IQR is equal to Q3 minus Q1, which is in between Q1 and Q3 average. So IQR is nothing but interquartile range. It is a method for detecting the outlier in the middle, which is 50%. Between 25 and 75 is nothing but 50. That is called as IQR. And then outliers, what outliers means is if the particular feature, consider it as median income. If it is less than the lower bound, okay, lower bound is nothing but below 25%. Or if it is greater than upper bound, it's nothing but above 75%. If it is less than 25% or greater than 75%, then it is called as outlier. Outlier is nothing but outside the particular range. That is called as outlier. That will be plotted. For example, outliers is nothing but, so this is the box plot, right? Outliers is nothing but these points. This is minimum, this is maximum. The point outside minimum and maximum are considered as outliers. Here the box plot of this is the box plot for house age feature. Here there is no outliers because there is no points here. Okay, consider, so for the box plot, so what is the minimum for house age? 1. Maximum is 52. Consider here minimum is 1, maximum is 52. So this line indicates minimum, this line indicates maximum. So these three lines indicates quartiles. Let's check here. 25%, 50%, 75%. 25 is 18, 29, 37. So here 18 is Q1, 29 is Q2, and Q3 is 39 or something. So 29, 18, 29, 37, right? 18, 29, 37. This is Q1, Q2, Q3, and this is minimum, this is maximum. From this is the box plot we have drawn. Since there is no points outside minimum and maximum, here the outlier is 0 for house age. See here, outlier is 0. And let's consider as median income. So there are many outliers. This is minimum, this is maximum, right? So there are many points here. So there are outliers which comes in median in, that is 681 outliers are presented. And let's consider an histogram of house age. So housage, so this is housage. Housage is plotted along x-axis and the count or the number of peoples are plotted along y-axis. So this is the number of bins, which is 30, I think, which we have used. And here this is the KDE, okay, kernel density estimate, which is the smooth curve. So this means the between between 0 to 10, there are, I think it's 400. So the number of people whose house age is between 0 to 10, and maximum there are 1 to 50 peoples whose house age is between 10 to 20, and there are around 1700 people count whose house age is between 30 to 40. So this is how we can draw the insights from the first graph. So similarly we will means there are the maximum peak here is, I think it's 1700 or something, 1700 count of people whose house age is between 30 and 40, whose house is 30 to 40 years of age. Like that we can draw a smooth curve of it. And similarly we can, as I have already explained, we can plot a box plot for the same, and then we can draw the outliers, and finally we can print the summary of mean, standard deviation, minimum, maximum, 25th, 75th, 50th, 25%, 50%, and 75% quartile. So this is about first program.